Good evening, everyone, and welcome to the May 2021 edition of Pittsfield Green Drinks. I'm so glad to see you all here, even if only as tiny little squares. Some important things to know. We've been doing this for over a year at this point, so I think you all know your way around Zoom, but in case you don't, here's a quick helpful screenshot. And please remember that if you have your video camera on, we can see you. Don't take us to the bathroom or fall asleep. We are the Berkshire Environmental Action Team. We protect the environment for wildlife to support the natural world that sustains us all. We have three main areas of programming, watchdogging, education and outreach, and stewardship, and you can learn all about that on our website, the Beat News, where you can also find our community calendar that anyone can submit to as long as their event is related to the environment vaguely. One of the main things that I do as education and outreach coordinator is I produce our weekly newsletter, the Beat News, which you can sign up for on our website. And that includes our community calendar and environmental jobs board, the environmental monitor and public notices, which has to do with Massachusetts laws regulating how human development impacts the environment. And tonight we are here to talk about an innovative renewable heat setup coming to the Berkshires with Brian Jerose from Agrilab Technologies and Rosemary Wessel from the Old Stone Mill Center. I'm really excited to hear about this. Rose is going to start us off. Rose is also the program director of No Fracked Gas in Mass, which is a program of BEAT, and she is a stalwart fighter for environmental justice, for sustainable living. She is a forager and just all around nature enthusiast and how to be a better human on this planet. So, oh, I'm sorry. And so take it away, Rose.
Okay, thanks. Oh, I got to get to the right screen before I start. So share screen. I like the saying that activism is the rent that we pay to live on the planet. I think of that every once in a while. If I think it's all too much, I remember how much it matters. All right, I hit the wrong button again. Let's see if I can scoot over enough to do this. Done and present. There we go. So thanks everyone for coming. This is a really exciting project we've been working on developing for a few years. It's a modular compost heat recovery, distributed thermal energy for buildings. And we're working on this with Agrilab and also Alpine Solar and also Ted's company, whose name I can't remember off the top of my head. Capital Energy, thank you. So I'm the clean energy coordinator for the Old Stone Mill. It's a building in Adams, and Stu Besnoff from Alpine Solar and Jason McCune and Brian Jerose are from Agrilab, which is a company in Vermont that normally works with farms and other similar agricultural businesses. And then Ted Butler, who works on investment in clean energy. I see, there we go. So about the Old Stone Mill Center. Old Stone Mill Center is a zero waste makerspace in Adams, and it's dedicated to taking industrial surplus and upcycling it into usable, durable items of all sorts. It's a historic mill building. If you've ever driven up Route 8, I'm sure you've noticed it just before you get into the center of town. Caught my eye for years when I was driving by. And then one day my friends Mike Augsburger and Lenny Freed said, "Oh, we bought a mill building in Adams." I said, "Is it that really beautiful one?" They said, "Yes, it is." So it's originally from 1860 and has been a woolen mill and a wallpaper factory during its time. The programs that they're working on right now are diverting thousands of pounds. Actually, I think it's measured in tons of sheets, blankets, chef's shirts, and other cast-off linens from Aladco, which is a company right down the street from them. A lot of it goes to homeless shelters. It goes to other agencies. It gets distributed wherever it can be used. And they also work on a program that Lenny actually started long before they started the mill, is converting brewery grain bags and farm feed bags, birdseed bags, and the like into reusable shopping bags. It's known as the Bag Share program. You might have a chapter near you. They're all over Massachusetts. There's also rehabbing and adapting used bicycles. And one of the more exciting projects lately has been rehabbing some of them and adapting them for use in the Republic of Congo. It started with a woman in Great Barrington who is originally from the Congo, came for linens. She saw all the bikes and said, "Oh, these could be so useful." And Mike had already been working on a project to make them handy for use in countries where that's the main mode of transportation for hauling things. So they just shipped off a bunch to the Congo and are continuing that program. And the mill also has an art studio, framing shop, machine shop, a sewing room, and they're always thinking of more programs, skill trainings, and classes. So it's worth following to see what they're up to. And as clean energy coordinator, when we were talking about how to do energy for the building, we were reminded that there was a gas hookup right out at the street. And I said, oh, heck no. So we're making sure that we are not using fossil fuels. Our goals for the building are to be a net energy producer that contributes to the grid. We had BPVS, that's Berkshire Photovoltaic Systems, look at the roof at one point and give us an estimate. They think we could probably produce almost 73 kilowatts of photovoltaic if we can get the funding to shape up the roof and get that installed. We're looking to attain the lowest possible energy demands by maximizing efficiency. One of the ways we're doing that is to develop the building zone by zone. And that way we can try different experimental energy projects for heating each one of those different zones. We're looking to use the most simple and low impact, low tech methods possible. One of the experiments that Mike tried on his own was making a solar collector out of cans and putting that in the window. And in the middle of the winter, we were getting 70-degree heat pouring out of there. So there are ways to do it as low tech as possible as well. But we really want to encourage experimental energy production that contributes to a wider discussion of what's possible. And that's kind of where this came in. If you look at the photo here, this was our original plan for compost heat at the Old Stone Mill Center. It's called a Payne mound, named after farmer Jean Payne, and it's just basically a coil in the middle of a big compost heap. And we realized this is smack in the middle of Adams in a pretty urban and certainly heavy residential neighborhood and right next to a river. And it might not be the most hygienic way to go about it. And that's when we heard about the guys at Agrilab and how they were turning manure reduction into heat generation as well. So we contacted them and said, how can we do this better? And with that, I'll turn it over to Brian Jerose.
Awesome. Thank you, Rose. Thank you, Elizabeth. And thank you everyone for coming to check this out. So the next slides will go through some background of how we got to this point, and then get into where we're hoping to go specifically with the Old Stone Mill Center and some other partners. So as Rose mentioned, I'll move my Zoom screen out of the way so I can see better. We're based in Vermont, northern Vermont specifically, and myself and other folks have been working in composting on farms and with other commercial businesses for a number of years, but was fascinated by how much energy and heat comes off of a big active compost pile. So ultimately, after a few projects, we found some partners who had done more with this, some of them with the Jean Payne mound, some with aeration systems, and had a project near where I live in Sheldon, right near Enosburg Falls, Vermont, just a few miles from the Quebec border, and brought in this group Agrilab from Windsor, Ontario, that had a heat transfer technology from compost. So we've been working on it for, hard to believe, close to 20 years now in some shape or form. But what we've developed into a company is really we're registered as a farm equipment manufacturer, but we do a lot of other consulting and services around putting these projects together, a lot of the planning and development and then helping people install and operate these units. But we've come up with the term compost aeration and heat recovery. So the distinction from that Jean-Pain mound that Rose talked about is we're actively pulling vapor out of the compost pile as part of giving it more oxygen, and all that hot vapor gets pulled into a specialized heat exchanger, and we heat up a hot water or glycol loop similar to solar thermal or geothermal. So that's the origin of that term at compost aeration and heat recovery. Certainly we started working mostly with dairy and livestock farms, being in Vermont, and other work I'd done in New York. And I've also gotten to work with commercial and municipal composting facilities. And over the last few years, we've actually done installations around much of New England and the Northeast, and within the last year and a half, a good sized facility in Burton, Michigan, right near Flint. But we've always been interested and had a lot of at least inquiries for people to do heat recovery from compost at different scales, whether it's horse farms or homesteaders, and then ultimately the Old Stone Mill Center. So it's something that we've looked at over the years and trying to how to downsize this to make it economical at different scales. So we were thrilled to have the opportunity to work with their team and start exploring this more seriously. Just some quick images to show, again, the scale that we're often working at is much larger. This is a farm, Catlin Farmstead in Winchendon, Mass. That's our equipment that we brought down and basically has a big aeration blower that puts that suction or negative aeration on a pile. And we're dealing with batches that are often 100 tons or 180 or 200 cubic yards of volume at a time. And there would be 4 or more of those. So some of these sites are producing as much as 10,000, or the one in Michigan, over 30,000 cubic yards of product a year. So at those scales, there's a lot of heat. So it's a little easier to glean off large volumes of energy. I like this picture to show an example of an installed system. It doesn't really show our equipment other than the pipes that lead into it, but there's 5 or so piles that you can see, but under the snow, there's these 8 rows on a composting pad with aeration trenches, and then pipes go underground. But the point being is, even with a snow cover in February of 2020, at the shell of the pile, the inside of the pile was 150 degrees. So we were able, through insulated pipes, to be drawing that vapor in. It helps speed up the composting process by giving it more regular oxygen, helps avoid odors that can happen when they, again, run out of oxygen, and pull all that hot, steamy vapor over the specialized heat exchangers and heat up a water loop. And at that site, it heats up their shop and sales building's floor. One more example, closer to us in Middlebury, Vermont, a company called Vermont Natural Ag Products, the Foster Brothers Farm, and maybe some people have seen bag products called Moodoo. So this is where they make that. And they still have a big straddle turner that's like a giant tiller that mixes and blends these piles. But part of their site we now have set up with these aeration trenches. So you may be able to tell that shipping container at the left, which has all our equipment inside, that pipe sticking out of the top has a little bit of steam coming out of it. And basically we're sucking it out of those piles that are sitting on the pad, again, through underground pipes that are insulated, and they're able to use the heat for everything for a 10,000 square foot bagging facility that they have nearby, as well as we convert it into a drying function. So some of their product that's finished but a little damp, they can dry it down before running it through a screener to sift out the fine and coarse particles, as well as to make it dry and stable before they put it in bags and send it to garden centers and so forth. So again, just to give the context, we're often dealing at larger scales with bigger facilities, but thus the challenge. The next couple slides, just talking about some of the other members that we brought in to the team. So us being in Vermont, 3 to 4 hours away from Adams, Rose and Lenny and Mike suggested to get in touch with Stu Besnoff, who's a experienced solar installer and service technician, and has a lot of experience with the hands-on of connecting not only the electrical and mechanical systems, but plumbing to get the solar thermal out of the system, and provided us with confidence that we wouldn't be asking Lenny to wake up in the middle of the night and flick a switch or drain a pump, or I'm teasing a little bit, but basically that we have some additional mechanical support on our team, both to make sure it can run reliably, but also to document the system in terms of what's the level of maintenance that would be required to routinely service this if this was to be done at a number of sites. But also a lot of insights and just to deploying renewable energy systems in general. Ted Butler was another individual we found through a little searching, and was kind of another way to round out our team. And we'll circle back to this, but Ted has a lot of construction project management experience and working on big institutional and commercial construction projects, but also looking at the economics of these renewable energy systems and creative ways to finance them, so that these facilities can make it a little easier, knock down some of the barriers to implement it. And also as part of that network of Greentown Labs, which is a lot of innovative and energy related companies in Somerville, Mass. All right, so to get to, again, I gotta move my screen here a little bit because I'm blocking part of my slides. But here's the problem. As Rose mentioned, we burn a lot of fossil fuels in our society. So obviously with a lot of impacts, but just in Massachusetts alone, the research we found was $18.5 billion on heating facilities. So it's staggering, and that education to us. So there's a huge market opportunity for alternative heating, even just in Massachusetts alone, not to mention nationally and globally. And again, all of us were motivated more than just by the business opportunity, but with the climate crisis, and we've got to find out some better ways, even if we don't know exactly how we're going to get from point A to point B. We all know we need to work on it. So this was our another opportunity to work towards solutions. Specific to what we know, the opportunity is related to compost. So that picture on the right shows that steaming pile of compost. So when you get the right combination of carbon and nitrogen, whether that be leaves and food scraps or sawdust and manure on a farm, you can make a formulation with the right amount of moisture and the right amount of oxygen where these piles really start rapidly decomposing. And one of the co-products of that process is the respiration of all those bacteria and fungi, and they turn into a thermophilic process, meaning it's a high temperature decomposition, and 150 degrees is fairly common in a farm or commercial composting facility. So that's, again, goes back to the motivation for our business Agrilab Technologies, but it's also an opportunity to deploy at a different scale and a different model. Again, to the opportunity to displace all that fossil fuel consumption. And with a little research, there's at least 5 million tons of organic materials, and defining organic materials as leaves, wood chips, food scraps, manure, and there's likely more. That was just through some of the open source references that we were able to find. So there's an abundant amount of this material, some of it already being composted, some of it being burned, some of it being chipped and left along roadsides when people clear power lines or road edges. So what we proposed was to modify our compost aeration heat recovery approach, but instead of doing it on large 100-ton or 200 cubic yard windrows would be to put it in a modified roll-off container, thus the name the hot roller, and do aeration in an in-vessel unit, so inside that container. So and that we could potentially load it with hot compost and not have to do all that blending and material handling at the Old Stone Mill Center, but instead do it at another facility and then bring the already heating compost to the point where there's that thermal load or heat demand. So this image describes, or schematic describes, some of the typical process at a compost site. You have all those ingredients from food scraps to leaves to manure to other biodegradable inputs. So that's the raw. There's different equipment, whether it's just turning it with loaders or other tillage or turning equipment, or other sites have aeration. Some advanced facilities have almost the robotic tunnels where they have a big combination of aeration and turning. So there's a lot of different ways to do it, but it essentially goes to the mixing, the hot compost. Eventually it goes through its most rapid decomposition stage. Curing is where it starts to cool down and you start to get more fungal development. And for the people who are interested in building soil and healthy microbes, beneficial microbes for their gardens or other applications. And then that finished product could go out in bulk or bagged or other ways. So we're trying to basically divert some of that material that's already being processed at, I think there's at least 70 or 80 facilities around Massachusetts and hundreds around the region, thousands around the country that are registered, much less other farm compost sites that aren't even in official databases. So our approach would be to take our modified roll-off container, that's its own small aeration container, have an experienced operator that's making hot compost mixes already, load some of that into a container, and then that container gets driven to the point of use again, in this case, the Old Stone Mill Center, but it could go to a college or a municipal building, a town garage, or even someone's residence if we have this process low maintenance, sufficiently low maintenance. But the composting then occurs right on the site inside the container. There's gaskets on the door. There's a cover on the roof that provides some low pressure so we can contain it. And then after some period of weeks, depending on the mix and how aggressively it's aerated, it could be anywhere from 4 weeks to 8 weeks. That material can, if it's not able to be dumped and used on site for landscaping or gardens, it can be brought back to the compost site and go back into that curing and finished product steps. So we're basically just trying to tap into some of the existing infrastructure and then move that energy source around. So sometimes I refer to it as a slow motion wood stove. So some people are familiar with the outdoor wood boilers that some people like them because you only have to load them once a day or twice a day. This you'd be loading once a month or some frequency like that. A little more zooming in on how it works. So the heat cap, the container on the right is the hot roller or that containerized compost aeration and heat recovery unit. So we have then a mechanical unit that has a blower, a heat exchanger, a circulator pump, and a control panel and condensate collection. So that's that mechanical skid or frame that's set to the side of the box. And through the connection of about 4 different pipes, we're able to either push air into the bottom or pull air down from the top. And basically, even though that compost is not being turned or agitated, we're able to push and pull air from different directions so that we can evenly compost that mix of biodegradable materials and not get any dead spots or uneven pockets of compost. So that was one of the technical challenges for making this work, as well as any leachate or condensate that forms in that process at the bottom of the container, being able to capture that, irrigate it at times back to re-wet the surface, or have it be sent to another appropriate location. The red lines that run through the mechanical unit and towards the building represent the hot water and glycol mix. So again, I'll use that analogy of a solar thermal system. You know, instead of those solar panels being up on the roof and then circulating into the building, this is running that plumbing loop through the specialized heat exchanger. So just to try to explain it a little further, the hot vapor is being pulled out of the compost vessel. It goes over the heat exchanger through essentially a form of a durable specialized radiator, and then the fluid is circulated to the either radiant floor or baseboard or other type of modine type heater, or preheating water tank and storage. So circulate it to the point of use. So again, the whole process is dependent on having it be successfully composted. If the oxygen runs out, suddenly there's a stinky box of food scraps and compost outside of the building. So that's key to the success of this, is to make sure it's first of all a successful composting system that's not creating nuisances and makes a product that someone's going to want to use for soil improvement at the other side. But we have ways of kind of shutting off the air to circulate the heat and keep it warmer than we expected. Again, we got temperatures in the vessel up to 160 degrees. And then occasionally we monitor the oxygen levels. So at times when it gets down below 5%, we would open up there'd be a sensor that would open up a valve and be able to pull in fresh air for a while to bring up oxygen levels up to 10% or greater. The term biofiltered exhaust refers to that steamy vapor that comes out the end of the system. We can direct that into basically a box or a bin of wood chips. So the premise is some of the odors are largely like ammonia, kind of nitrogen-based compounds. So if you push that vapor into a carbon-rich bed of wood chips or similar material, that is effective at reducing the odors or eliminating them. So we did this at I'll visit that later some more, but that's a common practice on large scale, and basically modified that to a smaller scale. And again, it's important that this isn't dripping or leaking on the ground. So we have to have a system that captures the water generated through the process. So what did we do? So here's trying to make this from an interesting idea into a product that people will actually want to do. So with the investment of the Old Stone Mill Center and another group out of Iowa, Fair Carbon Exchange, and then some of our own time and labor, fabricated some of this equipment at our shop in Cambridge, Vermont, which northern Vermont. Essentially what we call the proof of concept. It's a test that it works as we designed, and did a series of test runs, and then iterative improvements on different things like the gaskets, the pumps, the blowers, some of the control systems. Then pilot would be is what we're proposing, and what that's the intent of what we'd like to do, is have this ready for prime time, or basically ready for bringing it to Massachusetts and Adams, and doing this on site and actually heating part of the Old Stone Mill. So a few more steps. We'd do some more prefabrication at our shop, and then do some demonstration in the field with our team and various partners. And then should this be successful and there's interest from the market, then the next step would be to produce multiple units, set up more of a logistical network, figuring out who would operate the business. Is this going to run like a residential oil service company, basically, where someone, instead of bringing around a tank of fuel to a bunch of homes, is running these hot rollers around to different colleges or commercial buildings, and maybe at someday residences. So here's what it actually looked like. So this is outside of our shop, and during the end of the winter 2019 into 2020, we actually heated we have a small, I think it's around 2,200 square foot shop, and we were able to use that 20-yard roll-off container, that blue dark container in the background, and then the insulated, kind of that silvery rigid foam panel are encasing and keeping warm that mechanical unit from the earlier drawing, basically, and then that white insulated umbilical cord, as we called it, runs into the shop. So that both ran the power and the data and communication wires to the control panel, as well as a PEX loop. So that was the hot water and glycol supply and return into our shop. The picture on the right is a view inside the shop, and again, the mechanical unit as it was being built. So that's what's encased inside that silver insulation. All right, so what's next as we start to wrap up here? Really we're looking for more partners and feedback on how we can get this actually in the field. We have certainly some technical know-how, but I think we still have some business questions in terms of how to deploy this. So and then also figure out what the actual challenges are for operating this at any meaningful scale. So a few mechanical updates to some seals to make it more reliable, something that wouldn't need as much hovering over, something that could be perhaps checked or serviced on a week or bi-weekly basis by Stu or someone else with a mechanical plumbing background, and ultimately pilot this and be able to bring, as part of their educational mission, interested people to check it out and see if this is something that other people would be interested in as a source of fossil fuel free energy. And again, stressing that I think a lot of our work is on the business plans for commercialization. We did apply for some funds through the Massachusetts Clean Energy Center. So we had to put together some potential unit cost economics if we were able to get this down to certain costs for building both the mechanical unit as well as that container or containers at a larger facility. So here was a quick snapshot of how we calculated a simple payback, including putting a value on the price of carbon. So there is some speculation that and optimism that there'll be some payment for carbon benefits in the coming years. But again, I think while we're focusing on the Old Stone Mill Center because of their interest in the first place, some of the other interests that we heard from and anticipate would be a good fit are institutions. You know, you already have an educational mission. A lot of colleges have a sustainability mission as well. The municipalities, farms and greenhouses, similar to somewhat what we already work with now, but you could potentially serve smaller farms that aren't large dairies or livestock facilities, and then commercial industrial buildings. But there's the good news is, again, that market potential is huge on the heat side. There is far more demand for thermal energy for all this heating than there is there's more of a limited supply of composting biomass. But that said, it's still a significant millions of dollars of an opportunity, even if it done at any significant scale. So where we're wrapping up here, where we're at is we're seeking other partners and other opportunities. Are there other folks, and that's awesome that we were given the opportunity to share this tonight. Are there other institutions and other folks who would be interested to participate in any shape or form for this, getting to this next stage of development? And again, we need to refine the market opportunities and sharpen our pencils on the business side, because we know a lot of aspects of this are technically feasible. We are doing it. That's our that's our business on this larger scale. But can we make it economically competitive and attractive at these smaller and modular scales? We're aware of some grant funding opportunities, but perhaps there's other public, private, or other sources of funding to help get to this next level. And I think we're all open to the fact we probably don't even know what we should be asking at this point. So there's probably some other questions out there that we haven't even considered and asked yet. So that's the kind of feedback we're looking for. So thank you, and look forward to the discussion.
Thank you so much, Brian. I'd like to open the floor for questions. We are a small enough group tonight that I would invite you to just turn your camera on and unmute yourself and ask a question. If you're feeling shy, you can either raise your hand or stick a question in chat, and first come, first serve. So have at it.
And I was going to leave up the slideshow, and if anyone had specific questions, I could scroll back to that part of the slideshow if that helped answer the question.
Excellent. Sounds good, Brian. Thank you. Any questions from the crowd? We did have one emailed in earlier that I need to go find. Jeff Turner asks, how far is it being trucked in from? Are you able to use solids from a municipal wastewater treatment plant? Interesting. Have you searched hospitals?
So there is probably a reasonable transportation distance that it's economical. We arbitrarily picked 20 miles for a source of the compost. So there's a facility in Windsor, and there's another facility in North Bennington, Vermont, and there's likely other farm-based compost sites that we're not even aware of. So to generally ask that question, the closer the site is, the less cost and energy consumption on that transportation piece. But generally, the heating consumption is a larger consumption than the diesel or other transportation fuel source. So that's one part of it. As far as municipal biosolids, we have not used that yet, but there's no reason we couldn't. Personally, I would be cautious at our early stage to saying that we are bringing human waste and biosolids to the backyard of the old stone mill center in downtown Adams. Not because it may not be technically feasible. You probably could mix municipal biosolids if they're dewatered and blended with sawdust and wood chips and make a good hot compost batch. But I think not only with some of it's perception. So I guess that's my honest answer is being cautious for using that initially. I think it would be a great fit for a municipal facility that already has offices or a maintenance garage or other things adjacent to or in close proximity to that wastewater treatment plant. There may be less public objection to doing something like that. So I think it's technically feasible, but when pushing a new technology, I think you've got to be sensitive to perception as well.
I just want to add that, yeah, the Old Stone Mill is in a very, very residential neighborhood. So I would definitely say that perception would probably be the worst obstacle to that.
Yeah, this is Jason. I'm going to jump into, I'm the engineer with Agrilab Technologies. So I worked for Brian and did a lot of the building of the system, which was a lot of interesting challenges, a lot of fun, a lot of work. And anyway, yeah, I think, both of those things, you can put a lot of, the cool thing about this system is you can put all sorts of different stuff in it. So for something like the stone mill, you'd probably go with more of like a benign mix that was based on more wood chip or mulch kind of stuff. Perhaps a farm manure is something that's not as potentially noxious, but for an industrial site, you could definitely use a lot more, things would be acceptable. And the biggest challenge is not just any health concerns, but it's hard to keep all the biggest challenge we came across on the way. We're able to build this, the concept works, but it's difficult to store I would say the thing we're working on mechanically most is keeping all that water and all the odors inside the vessel, because anytime there's a little leak, you'll get some odors. And so if you have a benign feedstock like wood chips, then it's not going to really smell that bad. Like one of the batches we ran actually smelled kind of like fresh bread outside the shop. But if you were using something more like sewage sludge, it'd smell a lot worse. And some of the other batches we got that were more heavy in food scraps did not smell very nice out here. And fortunately, we have a shop we can test it at where there aren't really any neighbors around that are very concerned. But
I will qualify that is at the far end of our shared building, there is a church. So that was where the biofilter came in handy, where we definitely directed that exhaust into that small wood chip box, and we weren't routed out by the churchgoers for fouling their neighborhood. So
yeah, nobody complained, which is great.
And
but we're still working on that
too,
piece, yeah, to get it really urban ready.
yeah, I would add too, we went up for seeing the unveiling of the compost at the curing stage, you know, when it was really starting to cook down, and it was popped open and it was full of mushrooms and it smelled wonderful. So it was a very, very beneficial soil that ended up in that mix. And it was really amazing to see how many different cultures of mushrooms had populated it before it was dumped out.
Jane Wynn, that's a really interesting point, Rose. Jane Wynn is also bringing up one of the problems with municipal sludge is toxic chemicals, both from prescriptions and also from personal care products that are emerging contaminants, which are quite scary, which you would need to, I don't know, I guess you'd need to filter for that. Or Jane, do you have thoughts? Because I mean, municipal solid waste is a serious, it's a serious issue.
It's a serious issue, and looking at various sludges and what they're not tested for, or EPA says, oh no, we don't test for it. Food and Drug tests for it. Food and Drug says, no, it's third party that tests for it. And if everybody thinks somebody else is testing, no one's actually testing. So staying away from municipal sludge sounds like a really good idea to me.
Well, theoretically, when we get this working, it will not emit any liquids or really any odors, but I still wouldn't be proposing that we truck sludge all over the place. But, you know, the concept of it is it would actually be very self-contained. And then the question is, you know, who within a certain radius can use this energy? The idea is we have all this energy on these compost sites. They can handle the material really efficiently. They have lots of stuff, but they don't really have a use for the heat necessarily on those sites. So kind of to that distance question, you know, there's kind of a radius where you can save a lot of energy and heat compared to what you would spend, you know, trucking it over there. So, so yeah, so sludge, we're not going to venture there anytime in the near future, but certainly for industrial sites that are across the street from a compost site, for example, the place we have in Flint, the industrial system we have in Flint, you could easily picture some of the industrial buildings like across the road from them using something like this, where they could basically just move the dumpster or a box of this compost across the street and heat their building with it. And they're already right next to a compost site. So they're, you know, already kind of used to that atmosphere more than a residential neighborhood would be.
I'm curious, have you considered like food scrap compost collection for very small residential iterations?
Yes, but to part of the reason that we would, at least our early approach would be to work with a existing facility is because of that need to blend. This isn't like you can just pull off the top and throw in your food scraps and they get blended. To really have a good composting process and not have those nuisance, you need to get those wood chip and sawdust and leaf particles intermixed and intermingled with the food scraps or manure or those nitrogen rich materials. So there's definitely some discussion and concepts around it, because the idea that you could backhaul food scraps from a college or another location or a residence and then be able to then have that heat right at the spot. But and it's the mixing and blending challenge. So maybe we'd have a compartment at the end where you could tuck a couple 5-gallon pails of your food scraps and have it tag along back to the compost site, and then they'd send your 5-gallon buckets back with some full nice finished compost. So there's some ideas around that, but the barrier is, unless you had a nice big blending device at your house or the location, that becomes a barrier in the system.
And,
yeah, and yeah, but that's great, Brian. I would also add that it's also the batch. Like if you want to have a lot of heat from this thing, you want to have a full batch of compost, so it's really all heated up, and you can use all that heat in your building. So it is theoretically possible to make a pretty good static pile if you put in some food scraps, layer it, and make a good sort of a lasagna, as they call it, compost lasagna.
Yeah.
But the thing is, you'd be opening it up all the time, and it would take so long to fill the vessel up. By the time you got to the top, you probably wouldn't be peaking at heat production at the bottom. So the concept here is basically to take not just all the feedstock and the blending at the site, at the compost sites, but also to basically get that full batch and be able to get the heat off it into your building or whatever your heat load is for a period of, depending on the feedstock, it could be 6 to 8 to 12 weeks, I would say, when it's really at its hottest. And then once it cools off, then you can, send it back to the compost site. They can continue to use that in their process and fill it back up with fresh stuff and bring it back. So it's also kind of a question of just having that volume to heat a building. Not very many buildings would create enough compost in their own waste products to heat themselves, the exception being maybe food processing buildings. But I have really thought, as we built this thing and was watching it, operating it and figuring out all these, it's really kind of a closed system. We have the air cycling, the biofilter, we're capturing all the leachate and re-irrigating that onto the pile. That it did seem like a cool spin-off would be to make a thing like this that isn't for heat production, but is basically a static composter that you could have it like a park and ride or somewhere where, people drive by regularly and people could just dump their compost into it. Instead of having everybody drive to one compost site, there could be many of these sort of stable compost collection containers, basically, that could be swapped out. So almost like the reverse of, using it for heat is using it to gather feedstocks and bring them back to a big site. But you wouldn't have to worry about odors and all that stuff. It could really hang out there until it's full. And then with all the monitoring, you'd also be able to keep track. You could have a sensor in there that could tell the trucking company when it's full, when it's time to service it or whatever. And it would really just save a lot of diesel, basically a lot of trucking costs, moving everything around.
Yeah, Jason, if I can chime in here, Ted Butler from Capital Energy. That's a good point. I'll touch on that a little bit. But one thing I've always thought was cool about this system is the equipment is all readily available, so that you see this container in the front of the screen. That's just it's a modified dumpster that's sealed and everything else. The piping, standard mechanical piping. On the mechanical skid, you see, that's a heat exchanger that you can buy. So we're getting all these parts are already out there available commercially, and we're putting them together. That's not to say that there's no competitive advantage, because the secret ingredient here is, first of all, Brian and Jason's expertise in the composting process. You hear them talk about all the, the secrets with mixing of the batches and everything else. And also it's the monitoring that goes into the equipment here. And that's what, controls the flow of air in which quantities and which directions. And that's in order to optimize the composting. So to these guys' points, there's composting that's happening, but it's an accelerated composting. It's not the same composting that you would get in the normal process. So they're really accelerating that process to make this a smart system and optimize, pulling out all of that energy thermal benefit. So, I just wanted to mention that.
Thank you.
Yeah,
oh, go ahead.
I was just going to say, yeah, this doesn't kind of to chime in with that. Yeah, we don't use any like rare earth minerals. It's all kind of common construction materials. So it's like Ted was saying. I mean, it's not like you can just go buy all these parts and put one together very easily on your own. But none of this is. It's more the assembly and the sort of concept overall that's novel. We're not relying on some fancy new material or something that has to be gone out and mined specifically for this kind of thing. So.
Thank you. I have a question from Trevor Hurst, who I hope can hear us now. He was having some trouble. Is there a minimum and or maximum size of building that you can heat? Can you start and stop the heating process depending on season and use of building? And is it mass licensed? I think that's clear that it's not yet because it's not in, is there a license that needs to be obtained?
So I'll take them in reverse order. If there's a license out there, we don't know about it yet. What there is out there for regulating compost is a different tiered system. Massachusetts, like a lot of other states, has a tiered program. So like at low levels, you're exempt. I think it's below like 100 cubic yards for like community gardens or backyard composting. Then they have a registration scale for farms, up to, you're still small, but maybe up to 1,000 or 2,000 cubic yards. And then you get into permitted facilities, like these larger facilities that are taking in food scraps or food processing residuals or thousands of yards of leaves in the fall or Christmas trees. As far as the heating load, no, there isn't a minimum size. These aren't super big heaters. If at best this would be equivalent to a small boiler. So if it was a big commercial building, or let's say a dorm at a college, you might need to have not just a 20-foot container, but a 40-foot long container. So it would be a bigger box, and you may need to have 5 or 6 of them. So that's a real constraint. These do consume space, but at a larger campus, you probably have some parking lot space that would be appropriate to do that. And you may not be able to satisfy the entire heating load of a large building, and we're certainly not anticipating being able to do much more than a small space within the larger old stone mill. But the idea is that we're shaving or reducing that fossil fuel consumption or other sources of heating power, thermal power.
So
I don't know if you can add to that, Jason.
45 of these.
In theory, yeah, you could just keep ganging them together. So if there was a big commercial garage or again, a food processing facility or some other place that had the space but wasn't generating the compost themselves, they could be swapping out 2 of these a week, and then they sit there for 8 weeks, and you have a nice slow motion compost stove to heat your building.
Yeah, it's a modular system. So yeah, you can keep adding more. And if you had a lot of containers, you can see in that picture Brian has up, we also made this one a little smaller because it's a prototype, and we just couldn't handle like a really large, we thought it'd be, and I'm glad we didn't try to build a bigger one for the first one. But certainly a bigger container, you could easily double it and it would be more efficient. But you can see in the drawing, on the left, there's that sort of mechanical unit. If you were in a building that was using, say, like 5 or 6 of these, you could kind of consolidate all that equipment, all the blowers and sensors and control panels could stay at that building, and then you just be swapping out the containers. So you can still take advantage of scaling it.
Right. Is there a minimum building size that you can heat with these?
I'd say there's more of a minimum size of a compost heater that would work. So once you get down, I'd say about half the size of the box you see there, which holds about, the box holds about 14 cubic yards once it's all insulated and has the aeration pipes in it. So about half that much, I think, would be about the minimum that would actually get all that hot, because you really need to get all the compost up to temperature before it's almost like the same as you light a fire in a stove. When you light your wood stove, you have to let it heat all the wood up, and then it all releases its heat efficiently. So you need a certain size to get an efficient release of heat of the compost, which I would think would be probably about half of what you see there, which would be about more like a trailer you'd pull behind a pickup truck kind of size, like maybe like a 5x10 trailer would be at the minimum in my mind.
And so for heating square footage, that would be what, like 1,000 square feet?
Well, it depends on your load. Yeah, you don't.
So maybe another way to answer that is in one of the 6-week trials that we did, the equivalent amount of propane propane, I think was 110 gallons.
Great.
So you can get to your answer of how many square feet through all those factors of what your R value is of your building, what temperature you're trying to keep that space. You know, certainly like we look at that sometimes with greenhouses. You know, if it's one thing if you're trying to just keep a greenhouse at 50 to keep you know, hardy winter greens alive, but if you're trying to keep tomatoes and peppers at 75 degrees, obviously there's a different, so there's a few variables to answer your question, but maybe the one way to look at it is the energy equivalent of the propane that we calculated.
I think that's great. Thank you. Ed Fitzgerald wants to know, is there a gauge on the unit that indicates when the compost is losing its effectiveness and needs to be replaced?
I'd really like to chime in and share my screen at this moment. Jason had a brilliant system of putting sensors in the compost box itself. Let me see if I can pull this up. This is a readout of those sensors. I don't think there's any compost in there right now, but you can see where 4 sensors were dropped in the center of the compost box itself. It's also taking the temperature of the in and out in the plenum. It's got the in and out from the shop itself, the in and out at the shop wall. So it's this huge system of sensors that he came up with, and I'll let him elaborate.
Yeah, we were basically tracking we track temperatures, and with the prototype, basically we want to make sure all the compost gets hot. So that's why we recirculate the air around in a loop. I put all those sensors in there to really check, like, is there a cold spot in the compost somewhere that we're not, you know, actually firing the whole thing basically. And yeah, that's, so that setup we had there, we could look at the graphs and see what was the trend in oxygen over time, what was the trend in temperature, and between like the oxygen and the flow rate of the air, we measure the airflow, and we also have the water temperatures and the compost temps. We can do a pretty good job of figuring out like where the compost is at. And basically when the temperature drops below like what you need, then that would be time to swap it out. At this point, we're still operating these manually, but certainly you could develop an algorithm that would just send you an email or, you know, make an alarm or something that says it's done. But
yeah, if it drops below 110 or 100, there's probably a threshold where you would say, okay, time to pull this box and move to the next one.
But it's really interesting. There's a lot going on. I realized when we recirculate the air, we can really pull the heat out of the compost pile. And there was times when we actually cooled it off too much. And then we were like, oh, maybe it's done. But then we'd slow down our heat extraction and it would heat back up again. And so we actually, you know, it's interesting. It really is a lot of, it's a dynamic system, but over time, we'll definitely be able to figure that out. And I think, especially with, it's just a one box at a time, it's going to be something that we can automate at some point, but now we're still playing with it, which is a lot of fun.
And it was really great to be down here in Western Mass and see what was going on in the box up in Northern Vermont during that test period. So it's available through internet observation as well, so you can monitor remotely. Yeah,
it's a really cool little data logger that if anybody's interested, they can ask us later. I'm happy to share. It's made up by, it's called the Web Energy Logger, that particular device, and you can hook up to 50 temperature sensors to it and connect it to your internet, and it'll just publish your temperatures. Most people use it for their home, you know, just to keep track of their heating systems, a lot of in their house, especially if they add like passive solar or something. But in this case, we put a bunch of sensors in the compost, which is way more difficult, but it still works really well once you get it all working out.
I want to invite any final questions or thoughts. Ed, did that answer your question? Yeah, great. Any from our late joiners, Eileen, or I think Donna might have been a recent joiner. No. Oh, Alicia wants to say, this is so cool. In the grant process, MCLA submitted a letter of support for this project. I will share this info to our sustainability committee. Excellent. Thank you.
Good to see you here, Alicia.
Alicia says, good to see you too. Brian, Ted, Jason, Rosemary, do any of you have any final thoughts that you'd like to share with us tonight?
I just want to thank the Old Stone Mill Center because they're the ones who really drove this this project. They were the ones who reached out to try to do something different, and were able to. Jason largely developed the scope of work for this project. First, we did some feasibility, and then after it looked like there was some potential and promise, it moved on to actually starting to build a prototype. So it's really exciting to work on a new renewable energy technology, and there's a lot of questions still, but I think the concept is successful. But now the question is, can we make this viable as a real alternative for people?
Mm-hmm.
And I don't know if Lenny or Mike want to say anything. Lenny's definitely here, owner of the Old Stone Mill Center.
Yeah, I just want to thank our team, Agrilab and all the other people that have joined together to make this experiment happen. And I just wish we could find another funder to bring it to the mill, because I really think we're at a turning point where if we could get the money this winter, we would really have something amazing at the mill. So if there's anyone at this meeting who knows of some grants or some funders or philanthropists, we would be very grateful, because we're ready to go. We have the space insulated and set, and I think we're just so close. So just send that out there to the people that so we can actually see it in action.
And the Old Stone Mill is a great place to come and see stuff. I mean, that's the mission, is to show all of these different ways of doing things. And it would be a great place to be able to show off this technology in action.
Mm. Well, I would like to thank you all for being here tonight. I want to thank, oh, I'm sorry, I'm a little premature on this. I want to thank Rosemary and Brian and Ted and Jason for being here. It's Brian's birthday today, and I want to thank Brian for sticking it out. And we will release you to go have dinner with your family. And before we go, I'd just like to invite you to join us at our next meeting on June 15th. We will be here unless you hear otherwise. And I would like to invite you to please give generously to help make more programs like this happen. You all are here for free. We all are not, and it would be lovely if you would help us stay in business. And BEAT has some very, very exciting new programs happening. We are planting. Keep an eye on the BEAT news. We have, a rain garden going in the next few weeks. We have a new home for BEAT. We have river cleanups and invasive plant species removals. And green drinks every month, third Tuesday. So keep an eye on your email for updates. And Jane, Rose, any final thoughts?
Think you hit it all. Well, thank you to all the people who made it possible for us to actually be buying our building. So we now have a real home.
Mm-hmm. Amen to that. Well, thank you all. I hope you get to enjoy some of this beautiful and long-awaited sun, and have a good night. I'll see you next month.
Thank you.
Hi, everybody.
All right.
Thanks for coming.
Thanks.